So we've got quite a bit of stuff to go through here, but what we're going to do is we're going to create a drop-in replacement for the Model 4P power supply here. In a previous video, you saw me drill some holes in this upper plate and mount the power supplies directly to it, and use a little adapter board like this, to use replacement switching power supplies. However, I didn't really like this solution because it required these holes to be drilled to mount the power supplies, and I decided, let's see if we can just create a full drop-in. Take the old one out, set the new one in, 4 screws, plug it in, and go. And that's what we're going to do in this video. So let me set this stuff aside to make some room here. Pull the printed circuit boards out. We'll get one of these released. So these are again from PCBWay, designed in KiCad. Very happy with them. For the price, just can't be beat. Boards out. You can take a little bit of a closer look at it. So this is the second run of this printed circuit board. The first run was close, but had a couple of issues. I used the wrong size pads here for how I envisioned this coming together. I had a 0.9 mil plate through holes rather than the 2 mil I have here. I added this extra screw hole here to more solidly mount the large power supply. So let's kind of talk about this, and then we will move on to actually making use of it. So this is a Meanwell RS15-12. It is a 12-volt power supply. It's nice and compact. This is one that'll mount here that'll be used to provide power to the monitor. It separates the 12 volts from the monitor from the 12 volts for the floppy drives and everything to help make the video more solid. The video is not going to react to floppy drive motors going on and off and head stepping and that kind of stuff. You don't have to use this power supply. There's a spot here where you could put a jumper in here at J6, and that would take the 12 volts from this primary power supply and jumper it to video. It's there. It's not something I would do. In the same way that the original Model 4P power supply, this may even have been true for the 4, I don't know, but this power supply has an isolated 12 volt output here directly for the monitor that's separate from the 12 volts up here for the rest of the system. And it was exactly to do what we just said, to help with, to keep the video nice and solid. I then got a Meanwell, it is an RT65B. This is a 65 watt power supply. I want to say this was 64 watt or 66. These are very comparable power supplies. And for physical size, the two of them together are about the same size as this. But they end up being a little bit bigger. But so power capacity, this is, very similar, and it's going to mount here. You can get these power supplies from James Co. or I mean from DigiKey, maybe James Co. I don't know. I find them on Amazon. In the silk screen here is the complete list of parts needed to complete the board, including the manufacturer part number and the DigiKey part number. I personally order from DigiKey. It's my preferred vendor. I do use Mouser as well. We've got a little fuse holder right here. That is the equivalent of this fuse holder here. That way the primary voltage coming in, the line voltage coming in is fused in the same way it was here in case something catastrophic happens. Apologies for the horn honking outside. We have a 3-pin here where the AC power comes into the system. have a little 2-pin guy here. This one's on 0.1 centers. That goes off to the system fan. Those aren't used. I'm going to need one of these, but I also screwed up and ordered the wrong size. So this is I think they're, yeah, 5 times 20 millimeters is what I went with. But I accidentally got ones with leads attached. I'm hoping I can just trim the leads off. We'll find out and get that in. These aren't used. This is the primary output to the Model 4 wiring harness. Video on the bottom, 2 pins here, and the system on the rest. Set this all aside. And the way I envision this working, and we'll see whether it'll work or not. Get one out, are these little jumper links, and the idea is they screw on and they drop down through these holes here in the printed circuit board, and by golly, the holes still aren't quite big enough. Or yeah, they are. This was supposedly 1.9 millimeter, and I used a 2 millimeter hole. Oh, those do fit, and it's not a tight fit, but it's a solid fit, which I like. So the idea being, at least for the system powers, you could drop the power down using these. I don't know. I have to think about this for the AC power. I don't like the idea of having 120 volts AC just exposed as bare metal there. Meaning I may take those. I don't know, I got to think about it. I thought about actually you could use wire here as well, so you had the insulation on the wire. But we'll tackle that problem when we get there. So let's slide some of this stuff out of the way. Let me pull 5 of these out. These are really inexpensive. They are brass internally and tin plated. I've got a little cover here to help make this power supply safe. So one of the issues here is these are a little bit too wide to actually fit in. Which kind of sucks. I couldn't find anything that would absolutely fit. But what I'm going to do once I find the tool is I have a nibbling tool here. And I don't know if you're familiar with this tool or not. I want to say you can get them about $14. You can take light sheet metal and you can nibble away little bites out of it. You can nibble away on printed circuit boards. Basically, you can see the jaw there kind of working in and out. If I got something I can throw in here, kind of a demonstration. We'll use a bit of the cardboard box. You can come in here just like that, take little nibbles out of stuff. Like I say, thin sheet metal, printed circuit board. And then you can use a file to shape it kind of thing, but it works really well for that. And I'm going to attempt to use it here to cut these down a bit narrower. They are essentially, well, they're essentially brass sheet material. And I should be able to take this, got to be able to see what I'm doing. Took a little bit more off of it than I wanted to. And do that. Clip the 2 sides off. Oh, that didn't work, did it? Set this up and see if I can get these. Doesn't quite fit in. It's a little bit too wide. Let me take this little bit off here. There's a little tiny piece there. And we'll see if we can take this one in just a little bit more. You could also just use wire here if you really wanted to. That would work as well. Come on. Sometimes it just can't be easy. Let's trim down the others. It's always interesting trying to bring a project like this together. Get parts that work, parts that are readily available, integrating the whole thing together. Getting a good design in KiCad. I have to say PCBWay has been really awesome for me. I placed a number of orders with them now. No, they do not sponsor me, but I've never really had an issue. I mean, the boards come from, I'm on the West Coast. This board was literally, the design was finished on a Sunday, uploaded to PCBWay for review that Sunday. It was approved. I paid for it Monday, and the boards were in my hand Wednesday of this week. I mean, how can that doesn't make sense. Anyhow, they got here in under a week. Maybe it was Saturday, Sunday. I uploaded, I don't remember, but they got here like in under a week from China to the US in under a week. It's been very consistent from PCBWay. They come DHL. Just, you know, it's worked really well. And is that one kind of, these are all, you know, they do move around as they should. Get a little more tension on this one. Now the other thing I need are mounting screws. So this is the version before this one, kind of the prototype version that had issues. I hand drilled a mounting hole here for the larger supply. Break these screws loose. I need to reclaim these screws. So these are M3 screws. These particular ones I'm using are 3mm long. I believe a 4mm would be fine. You could actually use a M3 4mm bolt. 5mm might even work. 6mm is too long. I would, I think, like to have a lock washer behind these. What still has a bite? Oh, what still has a bite is the parts that are soldered. So let me get all those screws dumped out because we need them all. These screws were a bit of a pain to find. I sorted through my junk box. I ordered some, but they are too long. Still working on finding the best source for them. So my idea here was you would take these and slide them through. Line up the mounting holes, which is a little bit tough to do here. That's interesting. See, the footprints here I custom designed in KiCad for these two power supplies. The data sheet from Meanwell didn't have all of the measurements I needed to do this. So some of it was eyeballed, some of it I measured myself. But that's the idea, is you can just drop it in. Tighten everything up, solder it, trim it, and bang, it's in and done. So let's now attempt the same thing for the larger one. Now I included frame ground on here. Go ahead and do the final tightening on these. So with this one, the new Meanwhile supply, you know, when you order it fresh, comes with this little snap-on cover here, and the idea being I can snap on there and cover that up, but the question becomes, should I add some insulation, maybe some heat shrink tubing on these along here just to better insulate them, and I may go ahead and do that. I think that would actually be a lot cleaner, and I could do the same thing with this. Use some shrink tubing. You know, maybe that's the direction I'm going to go here. So let's undo what we just, well, first off, let's get an idea of the length of shrink tubing we need. Sit someplace out of the way, please. I'm going to have to use, I think, this diameter. See, you're seeing this happen real time on the fly with me here. I've seen all this in my head and thought quite a bit about it, but until you actually put it together. So this smaller stuff might be, actually it is. I'm going to use this smaller stuff because it'll slide on. And then of course the act of soldering will help make it work. So let's kind of figure out the length we need here. So I need something to act as the cutting guide. It actually looks really good. I don't know if how well you can see down in there, but that's a really good length for these. And just helps make it a little bit safer. So I'm going to cut all of these to that length. Black again, so common earth and neutral are all black. The 12 volts and the incoming AC voltage will all be, or will both be yellow. It's not optimal. I might actually order, if I decide to create some production versions of this to sell, I would go with buying some shrink tubing just so that the colors match the standards. So, no, I like that. That's just a tiny bit safer, but it is safer. And I prefer the result here to be safer than the original power supply was. That's part of the reason I went with the switchers that are in the cases. I could have ordered open frame switching supplies, but then it's easy to get a finger in there and hurt yourself. And I'd prefer this to be as safe as possible, because there are potentially people out there with not a lot of background in electronics with a dead Model 4P who could use something like this, and I'd like it to be as safe as possible for them. If I decide to make this something that I'm actually going to sell, I haven't made that decision yet. May just order the blank PCBs, which would be the easiest, or maybe even just throw them out in the open hardware world. I am going to release, the thing I'm also discovered is I'm going to release the tension here, and I'm going to square up this supply. It wasn't square to the board, and that was the tension. through those little mounting pins there. So let me square that up. That's much better. Some of those are really wedged in well. Two of them come out on their own, and two do not want to come out. These two have little sharp points on them, and that's what caused them to jam in there. Go with a bit of black. A little bit of a tricky spot to work into. Go with black again. And black a third time. These are full inch long, and I could probably actually use the 3/4 inch ones here. I did buy 3/4 inch ones and 1/2 inch ones just so I'd have an assortment. And like I just said, the 3/4 inch ones would probably be sufficient here. We're going to have some waste and trimming on these, but that's okay. You know, this is, you know, the attempt at live unit, you know, production unit number 1. Don't really consider it a prototype at this stage. I've built it a couple different ways as prototypes. Let me fire up the soldering pencil here. See if I've got an appropriate tip on it. I guess actually while we're here, let's get this so it'll sit flat. Make soldering on the backside here easier if it'll sit flat. That's square definitely there inside of the silkscreen markings. You can see that these mounting holes aren't exactly perfect, even though I measured them from the data sheet. And I guess I could come back and tune these a bit. That gets him nice and flush. Let's go ahead and solder the 5 of these up. No problems at all that I saw soldering there. Let me get the good glasses on to get a little closer inspection. No, I'm happy with those. Those look pretty damn nice. They're pretty stiff to cut. I expected that. Well, what do you think? I think that turned out pretty well. I like the heat shrink tubing. Let me find the cover here. Snap the little cover back on. We are at the point with, we've got insulation where all the leads come down through to solder on. These solder joints to me look really nice. Those trimmed well. A little bit sharp, but that's okay. This is fairly, you know, protected. You could still poke down in through here to produce a shock, but you know, for what it is and how it's meant to be mounted, I think that's perfectly safe. So let's wrap this first part up here with this, and I'll come back in the next part and we'll figure out how to get this guy wired up.